Yesterday, we kind of didn't really look at the unit circle, but we started to look at like at least the quadrants and the angles. We didn't fill this in radians though. If this is 0 radians, what's this in radians? Anyone remember? 1 pi, which means if I go full circle, how much is that? 2 pi. What's this? If this is 0 to pi, what's this got to be? Half a pi. And this has to be 1, 2, 3/4 of a pi. See, we've gone 3/4 of a pi to go all the way around to here. So, all right. Yesterday we looked at converting between degrees and radians. We looked at finding coterminal angles, including being able to state a rule that would find all coterminal angles. And we looked at calculating arc length and sector area when we had the angle in radians. Today we're looking at angular momentum of an object. Yes, sir. Thank you. Yes, this is 3/2. I don't know why I said 3/4. 3/4 would be over here. 3/2, because it's 1, 2, 3/2 of 2 pi. Thank you. 3/2, not 3/4. Angular speed. Or sorry, let's start with linear. Linear is the rate at which an object moves in a circular path. Linear, the rate at which an object moves. Guys, I'm not sure why you're talking, but it's picking it all up. In a circular path. And an example of the units we might use would be miles per hour, or feet per second, or meters per second, or meters per minute. But that's linear speed. Angular speed, well, it's not how many feet I'm moving per second or per unit of time, it's what? How many angles or how many revolutions or rotations? Yes. The rate at which an object rotates about a fixed point. In fact, some of you have an instrument in your car that measures this. It measures it in this. RPMs. Revolutions per minute. Oh, that's what that thing's telling me. All right, so here's the thing. We have linear speed is also called velocity. It's also called velocity. And it has a formula. The formula that we're given is S over T for linear speed. For angular speed, and we'll talk about what those are in a second. For angular speed, it's a lowercase cursive w, which is curved at the bottom, hence the W. And that's theta over T. T is time. What's S? Not speed. Arc length, yes. From yesterday, same variable. Arc length, T is time. Whereas W, the angular speed, is theta in radians over time. Now there's something that we're going to try to connect here. I want you guys to remember what S was from yesterday. The arc length can be calculated by multiplying two things. Anyone remember what it was? Theta by the radius, r times theta. Perfect. Good memory. All right, so if that's the case, then what is velocity really? Well, it's radius times theta over t. Does that make sense? Because I just replaced s. But wait a second. What's theta over t? W. This formula I find to be the most helpful when calculating linear speed, because usually I can easily calculate the angular speed just by dividing the number of radians by time, and then I already have the angle built in, so I don't need to find the arc length, I just need the radius. So I can just do radius times angular speed. Now all formulas are relevant, but these are the two that I primarily use. This angular speed and this linear speed formula. All right, we've got a vinyl record. It has a diameter of 30 centimeters. When played on a turntable, the record spins at 33 revolutions per minute. Find the angular speed in radians per minute. Find the linear speed at the outer edge of the record as it spins in centimeters per second. So guess what you're going to have involved in this problem? Some unit, nope, conversions, unit conversions, absolutely. They have centimeters up here. They want our answer to be in centimeters. That's not so bad. But here they have minutes. And the angular speed's in minutes. Yay, that's cool. But then this is in seconds. So we are going to have to do some unit conversion. For most of these, that's what we're going to have to, that's probably the biggest thing that trips people up is the unit conversion. So we'll look at that. So when I start these, because the linear speed can be calculated based on the angular speed, guess what I find first? Angular speed. So my angular speed is theta over t. Well, they didn't tell me theta, but they did tell me 33 revolutions per minute. Well, how much is one revolution? 2 pi. One revolution or one rotation, they may call it a rotation instead of a revolution, is equal to 2 pi radians. You go around the circle once, you've gone around 2 pi radians. So, in order to figure out what my angular speed is, all I have to do, look, it's already has the time unit there. I just have to do 33 revolutions per minute and multiply by 2 pi. Hello? Good, how are you? I'll let him know, thank you. Bye. Drake, you're out of here. All right, so we're going to multiply by 2 pi. If you like to do conversions this early on, you don't have to, but you could say 1 revolution is 2 pi radians. This gives me 66 pi radians per minute. That's an exact answer, but it doesn't make a ton of sense till we put it in decimal form. So that is 66, well it does if you know the unit circle. 66 pi is going to be roughly 207.3 radians per minute. So there's our angular speed. Questions on how to calculate angular speed. So I just take the revolutions per minute and multiply it by 2 pi. And if it's not per minute, if it was per 7 minutes, then I would have to reduce that fraction or divide. Now we have to find the linear speed, and we know linear speed is the radius times the angular speed. That's pretty simple. All I have to do is multiply this, 66 pi radians per minute, by my radius. What is the radius of this anyhow? The diameter is 30 centimeters, so the radius is 15. So I have 15 centimeters times, I'm not going to do the 207.3 because I don't want to have a rounding error. I'm going to do it times the 66 pi radians per minute, and I'm not going to write radians. When I multiply radius times radians, that unit goes away. I just have the centimeters then. So this is what I have right now. That is the angular speed, but what is it in right now? Centimeters per minute. Is that what I want it to be in? I want it to be in seconds, so I need to continue the conversion. I need to get rid of minutes and go to seconds. So I need to get rid of minutes by putting it on top and going to seconds. And 1 minute is 60 seconds. So now I'm going to multiply across the top, multiply across the bottom, and divide the two. So I have 15 times 66 pi times 1. And then I have to take that number and divide it by 1 times 60, so just divide it by 60. I get 51.8. 51.8 centimeters per second is my answer for the linear speed. 51.8 centimeters per second. So really, once we found the angular speed, how do we do that? We just took the revolutions per minute and multiplied it by 2 pi. Then to find the speed, or the linear speed, I just multiplied by the radius. That would have been the angular speed, but it would have been centimeters per minute. They didn't want it centimeters per second, so we had to convert to seconds. Questions on that? All right, here's a child. Maybe his name is Ben. I'm not sure. He's spinning a rock at the end of a 2-foot rope. How many of you have ever done that? Yeah. I did that with a camera once when I was a kid, and it didn't end well. The camera cord broke, and the camera hit the ground and shattered into a lot of pieces. It was on a cord. It was a camera. It was one of those old, and it had a little thing to help you carry it. And I spun it around on my finger here, and the cord actually snapped down here. The camera shattered to a million pieces. So anyhow, they're spinning this around. Is he spinning it around a fixed point? You betcha. That point right there. So what's the radius of this thing? 2 feet. The rate of 180 revolutions per minute. What's that gonna help us find? The angular speed. So our angular speed will be the 180 revolutions per minute times 2 pi. That'll give us radians per minute. This is 360 pi radians per minute. If I put that in my calculator to get a decimal approximation, it's roughly 1131 radians per minute. That's my angular speed. They didn't ask for that. I don't really need it as my answer because all they asked for was linear speed. But we know to find the linear speed, we need to know the angular speed first so we can multiply it by the radius. So right now, if all they asked was for what's the linear speed, I would just say multiply this right here, the 360 pi RPMs, by your 2 feet, and you're good. You'd have it in feet per minute. So 2 feet times 360 pi radians per minute, and I'm just going to write it over 1 minute. Right now I have my answer. If I multiply that out and divide, it'll be in feet per minute. But that's not what they want. They want miles per hour. So we have to convert both time and linear units in order to get our final answer correct. So which one do you guys want to do first, time or linear units? Time? Time's easy, right? So we got to get rid of minutes. It is 60 minutes to every 1 hour. So if those of you who had regular Chem, they told you to do this one thing at a time. So if you have this number, 720 pi over 1 minute, and you want to multiply it by 60, that's fine. You can do that, write that down. You can do decimals, but don't clear them out of your calculator because you don't want to get a rounding error. So we've got it now. Now that we've canceled out those minutes, because I have them in top and bottom, I'm now feet per hour. But I don't want it per hour. I want it per miles per hour. Actually, I want miles per hour. So how do I get rid of the feet? Correct. I need feet on bottom and miles on top. How many feet is in a mile? Raise your hand if you know. Alex. Correct. 5,280 feet in 1 mile. We've now eliminated the feet units and moved to miles. So now when I multiply across the top, multiply across the bottom, and divide those two numbers, I will have miles per hour. So I don't really have to worry about this right now because 1 times 1 times 5,280, but here's the idea. 2 times 360 pi, don't forget to put the pi in, times 60 times 1. There's my numerator. 1 times 5,280, there's my denominator. I'm supposed to divide my numerator by my denominator, and it gives me 25.7 miles per hour. 25.7 miles per hour. Please try letter C. All right, so let's take a look at this. You had 300 times per minute. If you multiply it, and that's per minute, so 300 per 1 minute times 2 pi is 600 pi radians per minute. And in your calculator, 600 pi is roughly 1884.95, so 1885. No? 1885 radians per minute. But I'm still going to keep this because we might need it if they ask for linear speed. The point on the thread of a tire with a diameter of 36, which means the radius is 18. Do I need the radius for angular speed? No, but I might if we then have to find linear speed. 70 times is what it's rotating for every 2 minutes. So that's 70 times, or rotations, per 2 minutes, which is actually 35 rotations per minute. You could just reduce that now, or you could just multiply it by 2 pi. That's going to give you 140 over 2, which is still 70 pi radians per minute. And 70 times pi is roughly 219.91, or roughly 220 radians per minute. But I'm going to keep this because it might help me in a second. All right, so if you got those, now see if you can find the linear speed of these same problems down below for letter D. All right, so we already had our angular speed, which helps because we know that linear speed is the radius times the angular speed. So you've got 600 pi radians per minute. Is it still on freeze? Thank you. So you have 600 pi radians per minute times the radius of 25. And that would be our angular or linear speed right there, just by doing that. But can I do just that and be done? No, because they asked us to convert it to meters per second. Which one do you guys want to do first, time or linear units? Time, that's fine. So there are, in 1 minute, there is 60 seconds. So now we've canceled out minutes and moved to seconds. So we've established the time we want. We need to go from centimeters to meters. How many centimeters is in a meter? 100 centimeters in 1 meter. So now I just multiply across the top, multiply across the bottom, and divide them for my, just doing that would have given me my linear speed, but it wouldn't have been in the right units. So we'd have to convert it in the end anyhow. So we got 25 times 600 pi times 1 times 1. On the bottom I have 60 times 100 times 1. Take my numerator, divide it by the denominator, and I've got 7.85 or 7.9 meters per second. Meters per second. Questions on that? Same thing for number 2. Just double check that the data is all the same, or the numbers are still the same. Yes, the radius is still 18 inches. That didn't change. 70 times per 2 minute, that's what the last problem said. So we already know the angular speed is 70 pi radians per minute. So I take my radius of 18 inches, I multiply it by 70 pi radians per 1 minute. And now that would be my linear speed, except they want it in miles per hour. Well, some of you might know how many seconds are in an hour. Anybody?
63,360.
Okay. Okay. So I'm going to, since most of us don't know that, I'm going to convert minutes to hours. Wait, is this minutes?
No, I made a mistake.
This should be easy, guys. Minutes to hours. 60 minutes is 1 hour. Now, the only other thing we have to convert is inches. Does anybody know how many inches are in a mile? That's the number you gave me. Most of you don't. So, how many of you know how to go from inches to another unit higher? Go to feet. So, inches to feet would be 12 inches per 1 foot. We're now in feet, but we don't want to be in feet, we want to be in miles. So we go back to the ratio Alex and several other of you gave us a little while ago, which is 5,280 feet in 1 mile. And now we'll have miles per hour, which is what they asked us to do. Again, if you took regular honors or regular chemistry, not honors chem, and you didn't do these entire conversion tables, and you want to get your answer like this, and then do a conversion, get that answer, do a conversion, get that answer, do a conversion, you're welcome to do that, but don't clear the decimals from your calculator because it will throw you off. So now on the top, I'm just going to multiply 18 times 70 pi times 60 times 1 times 1. And the denominator I have 1 by 1 by 12 by 5280. Take my numerator, divide by my denominator, 3.75 or 3.7 to the nearest tenth, 3.7 miles per hour. And that's it for angular and linear speed. You have a worksheet that matches to this. You will have to do unit conversions where you need to find angular and linear speed first. Have a great day.